Hi everyone, this is Reggie M. Hortiza and I am going to report basic pneumatics training. Let's go. Introduction of pneumatics. During the few decades, various automation techniques has been introduced in the field of manufacturing in order to enhance the overall industrial productivity. Among the various technologies that are playing important role in the rapid growth of Indian industries, fluid power is unique. During past decade, number of applications have been developed based on pneumatics. Pneumatics definition. The study of pneumatics deals with system operation with air or gaseous medium to impart power or to control power. The term pneumatics is derived from the Greek word pneuma, meaning wind or breath. Pneumatic power is the power that is transmitted by pressurized compressed air, normal air, compressed air, control valve, and actuator, a simple pneumatic system. Composition of atmospheric air. Dry air at sea level comprises 78.03% nitrogen, 20.99 oxygen, and 0.98 oxygen argon by volume. It also contains traces of carbon dioxide, hydrogen, neon, helium, krypton, and xenon. A part of gases, atmospheric air holds many harmful impurities like dust and etc. Air has mass and exert pressure on the surface of the Earth. Atmospheric pressure at normal sea level is 1.013 bar. Air pressure. Force is applied to the air enclosed in a chamber through a piston of area. The enclosed air is compressed and its pressure rise in directly proportional to the applied force and inverse proportional to the area of the piston. Unit of pressure. NSI system unit pressure in Pascal 1 and 1 PA is constant pressure acting on surface area on a 1 square meter with a perpendicular force of Newton. And 1 PA is equals 1 N over M and 2. For industrial pneumatic purpose, Pascal is the small unit for use in measurement and hence a more practical unit called bar is used. 100,000 Pascal is equals 1 bar. 14.5 psi pound per inch is equals 1 bar. Pneumatics application. Some industrial application employing pneumatics are listed below. General methods of the material handling: clamping, shifting, positioning, orienting, branching of material flow. General application: packaging, filling, metering, locking, dividing of access, door control, transfers of materials, turning and investing of parts, sorting of parts, stacking of components, stamping and embossing of the components. Pneumatic applications. Points which for 2, this is the example. Pneumatic cutter. This is how I look like pneumatic cutter. Standardization. Setup. Commit European transmission. Only hydraulic use at pneumatic case is a federation of European manufacturing which is involved since 1962. DIN or DIN, Deutsches Institute for Normung, and VDI, Verein des Ingenieur Association of German Engineers. VDM, Verdam Deutsches Maschinen and Allgemeine Engineers. Some pneumatic standards: fluid power system and component, graphic symbols and circuit diagram, port marketing or pneumatic direction control valve, mounting dimension of pneumatic cylinders, hydraulic and pneumatic system circuit diagram, and many more. Compressed air generation and contamination control. Typical pneumatic system. This is the typical pneumatic system. And next, air generation and distribution. The air generation of compressed air starts with compression. The spread air flows through an entire series of components before reaching the consuming device. The equipment to be considered in the generation and preparation of the air include inlet filter, air compressor, air reservoir, air dryer, air filter with water separation, pressure regulation, air lubricator, and required drainage point. Intake filter. It is used to clean and filter the air used for the system. Before the surrounding air enters the compressor, it must pass through a filter to remove most of the dirt and other solid contaminants. These filters can be of dry or wet type depending on the compressor manufactured and application. Air compressor. A compressor is the most common industrial energy supply unit that converts mechanical energy into fluid energy. It is designed to take in air at atmospheric pressure and deliver the received air to a closed system with a certain volumetric flow rate at a high pressure. Reciprocating piston compressors. A piston compress the air drawn in via an inlet valve. The air is passed on via an outlet valve. Reciprocating compressors are very common and provide a wide range of pressures and delivery rates. For higher pressure, multi-stage compressor is used with intercooling between each stage of compression. Reciprocating piston compressor. Reciprocating compressor consists of the crankshaft by a connecting rod. Crankshaft is externally rotated by electric motor. Crankshaft and connecting rod convert rotary motion into reciprocating motion. Flow compressor. This is how I look like a flow compressor. These are particularly sustainable for large delivery quantities. Flow compressors are made an axial or radial form. The air is made to flow by means of one or several turbine wheels. The kinetic energy is converted into pressure energy. In the case of an axial compressor, the air is accelerated in the axial direction of the flow by means of blades. Next, reservoirs. Reservoirs is configured downstream of a compressor to stabilize compressed air. Reservoir compensates the pressure when the compressed air is taken from the system. If the pressure in the reservoir drops below a certain value, the compressors will be compensate unit the set higher value in reach again. This has the advantage that the compressors does not need to operate continuously. Sir, and again, my name is Reggie M. Ortiza, BIT 2F student.